Welcome to this math channel. Today I am trying to solve this math Olympic problem with a very unique way. So let's find out the solution. As our equation is 4 to the power of x plus 1 here minus 4 to the power of x minus 1 here, that is equals to 5 here. So I am calculated the value of x here. So if I am wrote here with x, I am wrote here with what 1 is equals to 1, that is equals to I am wrote here 2 minus 1 plus 2 is become 1 here. So I'm replace this term with minus 1 plus 2 here. So 4 to the power of x plus 1 is become minus 1 plus 2 here, minus 2 here, minus 4 to the power of x minus, and this term minus 1 here, that is equals to 5 here. So now I'm using product of power rule. Product of power rule means if a to the power of m plus n here, this means we have separated out to the power of a to the power of m into a to the power of n here. So our equation will be look like that 4 to the power of x minus 1 here into 4 to the power of 2 here minus 4 to the power of x minus 1 here, that is equals to 5 here. So as we saw 4 to the power of x minus 1 here, so I am taking common here 4 to the power of x minus 1 here. So remainder is 4 square here minus 1 here, that is equals to 5 here. So the next step is 4 to the power of x minus 1 here, 4 square is what 16 here, 16 minus 1 here, that is equals to 5 here. So now if I further solve, this is 4 to the power of x minus 1 here, 16 minus 1 is become 15 here, that is equals to 5 here. So divided by 5 here, both side divided by 5, sorry 15 here, divided by 15 here, both side divided by 15 here. So this term and this term cancel, so 5 ones are 5 and 5 threes are 15 here. So our equation is 4 to the power of x minus 1 here, that is equals to 1 by 3 here. So I am using quotient of product rule. Quotient of product rule is defined as if we have a base a here, m minus n here, and power minus here, so this means we are separate out with power and negative term with denominator here. So our equation is 4 to the power of x here divided by 4 to the power of 1 here, because 1 here, that is equals to 1 by 3 here. So if I am using both side multiplied by 4 here, so both side multiplied by 4 here, so our equation is this term and this term cancel, we got 4 to the power of x here, that is equals to 4 by 3 here. So now I am further solve this equation. I am taking both side by taking log here, so log here and log opposite side of to the equal here. So log here mean we have power of log here with log of a to the power of b here, this means b log of a is considered here. So this is equals to x here log of 4 here, that is equals to log of 4 divided by 3 here. So quotient rule for log here, so quotient rule of log here with log of a divided by b, this means log of a minus and log of b formula here. So our equation is x log of 4 here, that is equals to log of 4 minus log of 3 here. I am taking both sides divided by log of 4 here, so taking both sides by divided by 4 here, log of 4 here. So this term cancel. We got x that is equals to log of 4 divided by log of 4 here minus log of 3 divided by log of 4 here. So now this term and this term cancel. We got what? X that is equals to 1 minus log of 3 divided by log of 4 here. So I'm using the change of base formula. So change of base formula is that if log of a divided by log of b here, similar above condition, so this means this look like log of a to the power of b here. So our equation and next step is x that is equals to 1 minus, this is base is b here, so b is 3 log of what? Log of 4 divided by 3 here. So this is not a general mistake here. This is a here and this is b here. That's the final answer. So let's try to verify to put in main equation. This is b and a here. Now put the value of x here in main equation. Our equation is 4 to the power of x is 1 minus log of base 4 to the power of 3 here and plus 1 here minus 4 to the power of 1 minus log of 4 to the base c here minus 1 that is equals to 5 here. So this is 1 plus 1 is become 2 minus log of base 4 to the power of 3 here minus 4, and this is plus and minus become cancel, minus log of negative log of 4 to the power of 3 here, that is equal to 5 here. So as you saw, power is I'm using quotient of power rule here. So our equation is 4 to the power square here, and this negative term goes to denominator side with 4 to the power of log of 4 and 3 here minus this is 1 here, remainder 1, and this negative power bottom side log to the power 4 and all 3 here, that is equals to 5 here. So this is, I'm taking LCM here, so this is 4 square minus 1 here LCM, and we got same LCM number here with 4 log of base 4 to the power 3 here, that is equals to 5 here. So this is 4 square is 16 minus 1 here divided by 4 to the power log of base 3 to the power 3 here, that is equals to 5 here. So this is 15 here, 15, and I'm using inverse property of log here. Inverse property of log here with, if we have log of a and into the power of a to the power of x here, this means they are equal to x here. So this is property of x here. So as we saw, this is power here. So as we saw, so if I'm taking this log here with power here, so this next step look like a log of a to the power of x here, that is equals to x here. So this means this term and this term cancel, we got final value of x here, and this is x is equals to x here. So this means 4 to the power of x is here with, this means they are equals to 3 here, so divided by 3, that is equals to 5 here, and 3 1s are 3, 3 5s are 15 here. So 5, that is equals to 5 here. We conclude that left hand side is equals to right hand side. So this can conclude that our desired answer of x is suitable for our main equation here. So thanks for watching. Keep like, share and subscribe please.